Chapter 4. Transfer processes. We will talk about the three different heat transfer processes, including conduction, convection, and radiation. 4.1. Conduction. Have you ever wondered how a polar bear withstands the very extreme temperature at the North Pole? Heat transfer is due to temperature difference between two bodies. There are three types of heat transfer: conduction, convection, and radiation. 1. Conduction in solids, liquids, and gases. Conduction takes place when two objects are in contact. Heat energy flows from the hotter one to the colder one through molecular collisions. Experiment 4A. Conduction in solids, liquids, and gases. The following experiment demonstrates and compares the conductivities of different metals, liquids, and gases.
In this experiment, we will study the transfer of heat by conduction in solids, liquids, and gases. Let's see how heat is conducted along a solid rod first. Evenly coat one end of a copper rod with octadecan 1-ol. Stick metal drawing pins at regular intervals along the coating. Heat the other end of the rod. Observe what happens to the pins. How is energy transferred along the rod? Now we will investigate what kind of solid conducts heat faster. Put a wooden rod, an iron rod, a copper rod, and a glass rod into a beaker of hot water. Feel the ends of the rods to find out which rod gets hot first. Which material conducts heat the fastest? Alternatively, coat one end of each rod with the same amount of octadecan 1-ol and immerse the other end into hot water. Observe what happens to the coating. Which material conducts heat the fastest? Now we will study the conduction of heat in water. Use a piece of wire gauze to keep some ice underwater at the bottom of a boiling tube. Gently heat the top part of water and observe the ice. What can you say about the temperature difference between ends of the boiling tube? Lastly, we will study the conduction of heat in air. Cover one end of a cardboard tube with a black disc. Put the tube near a radiation heater horizontally, with the closed end pointing towards the heater. Insert two thermometers into the tube near two ends. Turn on the heater. Take the readings of the thermometers after a while. What can you say about the difference in readings?
Different metals conduct heat at different rates. Water is not a good conductor, and air is not too. In fact, metals are mostly good conductors of heat, while air and foam are good insulators of heat. 2. Examples of conduction and insulation. A. Maintaining temperature. Insulation is a common method to keep warm. Warm-blooded animals have feather, hair, or even fur to trap a layer of air on their body to reduce heat loss by conduction. We human beings even wear gloves to reduce heat loss. B. Cooking. Cooking utensils are mostly made of metals with insulating handle so that the food is heated quickly and evenly. Chinese clay pot, on the other hand, is made of poor heat conductor. However, once heated to high temperature, it can keep its content warm for a while even after heating. C. Building. Foam is used as insulating material in building. Foam has a lot of small holes which trap air inside. That makes foam a good insulator. D. More daily life examples. Foam is also used to make food container to keep them warm or keep ice cream cold. When we touch a metal surface, which is a conductor, we feel cold. Metals conduct our heat away very quickly, lowering the temperature of our skin, and so we feel colder. Example 1. Cup sleeve. Cup sleeve is often made of thick cardboard that traps a layer of air inside, providing good heat insulation. If it gets wet, a cupboard cannot trap air, and so it conducts heat much better, failing to keep warm anymore. Do check point 1 below.